and welcome to Module 6, where today we're going to be talking about irrigation auditing. Now, today's module is really an overview of irrigation auditing, and it falls really under the umbrella of a larger site evaluation. So whenever you go out to do a specific irrigation audit with catch cans, you also want to be looking at the context in which that audit is happening. So we'll be talking briefly about both of those sections, as well as a closer look at some of the irrigation equipment that as an auditor, you would want to be taking a look at and making sure was operating correctly. So why conduct an irrigation audit? Basically, the idea of an audit is to gather data on how efficiently your irrigation system is applying water to the landscape. Typically, it's done with lawns because that is where oftentimes, you see the greatest stresses happening. So we're going to again talk about this in general terms, and then there is a separate video that takes you through the step-by-step of preparing for an audit, running the audit, and then we have another module where you learn how to actually calculate the distribution uniformity of that zone. So before we get into the details, we thought it was important for people to understand the different components of an irrigation system, especially if this is new to you. So we have this wonderful diagram here that shows you all the moving pieces, and then we'll go ahead and look at them in a little bit more detail. So we start with water coming in from the street. It comes in and it will flow through a water meter, which will basically allow you to measure how much water is being used by the site. That's where you get the readings. From there, the water moves into the property. In some cases, it divides at that point, and some of the water goes into the residence or the building, and some of it will go directly out to the landscape. And sometimes the water goes into the unit and then flows out from there to the landscape. So there's these two different ways that the water can move out into the landscape. Now, as it moves out into the landscape, there's a couple of key things you want to be looking for. The first one is the backflow preventer. So that is the thing that protects water from flowing back into your potable, your drinking water system. What will happen is when you turn your irrigation on and then turn it off again, there is this sucking thing that happens that pulls that water back in through the pipes. And if you don't have a backflow prevention system in place, you have the potential of contaminating the drinking water. So you want to make sure there is some sort of backflow prevention system. We're going to look at different options to that. Next up is your pressure regulator. So the water comes in from the water provider at a particular pressure. It's measured in pounds per square inch. Oftentimes it can be quite high. Certainly in our work, we've seen 50, 60, even up to 120 PSI in some sections. So crazy, crazy high pressure. Now, sometimes there is a master pressure regulator, and sometimes it is built into the valves themselves. And again, we'll look at that. And then from there, it's like you're passing all these different gates. We actually go out to the valves. And the valves come on one at a time, and each valve is responsible for watering a zone, a hydrozone. They cannot run simultaneously, so it is a sequential running. Sometimes the valves are underground, and sometimes they are above ground. And then after that, you are out to the specific delivery method. So at that point, you're either watering via spray or you are watering via drip. So big picture. Oh, you know what? I forgot the controller. So basically, you have the mastermind on the timing of those valves. And we'll be doing a separate sequence on that after this module. So let's go ahead and take a closer look at the backflow prevention. As I mentioned, this is a critical component. Here's some images of how it can look out in the field. The two images down in the bottom are what you would typically find in a residential setting. You have a pressure vacuum breaker, which is a mechanical way of preventing that backflow. And then you have an anti-siphon valve, which works with gravity. And then the image on the left, the reduced pressure vacuum breaker, is something that you would typically see in a commercial or an institutional setting, HOAs, et cetera. So typically you would see that when you've got a larger landscape area that you're managing. Now, of course, with everything, you obviously want to make sure that that equipment is properly installed according to the manufacturer's recommendations, specifications. So next up is the pressure regulator. People don't always understand the significance or the importance of having the proper regulation on that. You've got pressure that is required, for example, for your appliances to run correctly, but with your irrigation system, you also want to make sure you have the proper pressure. Now, if it's too high, you can see evidence of misting. It can damage the system, especially if you have drip. It can like blow the pipes apart, and it will absolutely affect the uniformity of your distribution. Now, you can also have pressure that is too low. And in that case, it's affecting the radius of your spray heads. You're again getting unequal distribution, and it really is not allowing the equipment to work the way it should. So you can have two different kinds of pressure regulation. You can have what we call a master pressure regulator, and that is what you find at the beginning of the system before you go out to the individual valves. And it will control the pressure of everything else that is downstream of it. Now, if your pressure is managed, it's possible that you will need to do some additional pressure reduction. And in that case, you could potentially see regulators at the valves themselves. So you can see the little 25 PSI or 20 PSI that is on a valve. So even the valves look a little bit different here. So we've got a couple of different examples. The first image on the left is a globe or angle valve. So those are valves that are actually below the surface. You typically see that again in larger areas or where there's a lot of topography happening, and it's a challenge to get the anti-siphon valves to work. If you have a globe or an angle valve, you do need to make sure that you have a mechanical backflow prevention system in place. Now, the other two images are our anti-siphon valves. So they have multiple, they work in multiple purposes here. They work by gravity. The image in the middle is an anti-siphon valve that you would use for a drip system. So you can see the filter on it and the pressure regulator. And then the image on the far right is for spray heads. So there you go. Now, the key thing about anti-siphon valves and them working correctly is that they work by gravity. And so there is a minimum height above ground that they need to be. 6 inches is the lowest minimal amount. Boy, retake that one. 6 inches is the least amount of height that you would want. You definitely want to check with your local codes to see what they are requiring. And the key thing to understand about anti-siphon valves is it's not just 6 inches above where they are, it's 6 inches above the highest head or emitter. So if you actually have spray heads that are higher than where your valves are, or you're irrigating in a planter box, for example, then your anti-siphon valve actually has to be higher than that. And then, of course, what are the different spray methods that you have, or the distribution methods? So here we have 3 different kinds. These are overhead spray. On the left is the rotary nozzle, which is newer technology, much more efficient nozzles. They're also known as multi-trajectory nozzles. In the middle are rotors. This is often used in larger areas. So if you've got estates, golf courses, play fields, that's typically where you will see the rotors. And then you have what we call conventional spray, which is the least efficient of these three distribution methods. And then we've got drip. So drip, again, a few different variables. You've got random pattern, which is especially when you are working with shrubs and trees, you don't need water everywhere. You need the water at the plants. So this is what we would call a random pattern. Then you've got the grid pattern, which you typically see when you're doing large areas of ground cover where you want a very equal distribution of water. And in that case, they are lined up at regular intervals, whether it's 12 inches, 18 inches, or 24 inches apart, and the emitters are built in. As opposed to the last image, which is what we call online irrigation or point source. And that is where you put in emitters only where you want them. So it's blank tubing, and then you punch in those emitters. Now, other equipment that you might see when you're out doing your visual audit, you might see a quick coupler, which is a place you can connect your hose. You might see an irrigation meter sometimes, and it's become required now. If there's a hose, you need a backflow prevention system at the hose bib. And if there's any sort of a smart controller out there, you might see a rain shutoff, although you can actually attach those even to your conventional or old-fashioned controllers. And maybe you wouldn't see this, but you might know that it's out there, a soil moisture sensor that is below ground and connected to the controller. So besides the spray heads that we talked about, the drip that we talked about, you might also see soaker hoses that are being used, bubblers that are being used, and we've already talked about the drip. Now, as far as the emitters, we do have some recommendations on how they should be arranged around the plant. Even though today we're talking about an irrigation audit, we'll be talking about it in terms of spray. This is a good time as well to talk about how to work with drip correctly. And so we recommend at a minimum 2 emitters per plant. It's just a fail-safe in case one of them gets clogged or moved. You always have the other. Obviously, the larger the plant, the more emitters. And the size or the flow of the emitters depends on various factors. One of the most key ones will be the soil type. Now, before you begin your audit, or if you're doing a visual audit, you want to take notes about the sprinkler performance. And if you're going to do a catch can test, you definitely want to make sure that those improvements are made beforehand. So you turn on your sprinkler system and you are looking for potential issues. So are the sprinklers blocked either by they're sunk too low in the grass, or they're actually being blocked by shrubs that have grown up since you installed that system initially? Is there misting happening in the sprinkler system? Are there heads that are actually broken or sunken or bent, and now they're watering the car as opposed to the landscape? And then, of course, when it comes to the turf, taking a look at it and finding out what or describing what it is that you are seeing. Is there evidence of stress spots? Does it look like there are definitely areas that are not being watered in the same way that perhaps other parts of the turf area are being watered? And then if you are moving forward with a catch can test, and again, the reason you do a catch can test at this point is really to understand in more detail how your irrigation system is performing, how that water is being applied, and are there areas of the zone that are getting either too much or not enough water, and then making the appropriate changes after that. So when you are preparing for the catch can test, and again, we'll go into this in more detail in the other video, but you're looking at two components. The first one is what are you looking at that will affect, or that is the context, if you will, for the irrigation system. So you're looking at things like slope, soil type, root depth, microclimates, etc. And then, as we mentioned, you are also looking at, quite a bit of detail, what is happening with the irrigation system itself. So, blocked heads, but you're also potentially looking at the valves, any leaks, uneven spacing, etc. All of that you put in place, and you get ready for your catch can test. We can't stress enough the importance of knowing what is happening with your soil, the soil type, the soil condition, the root depth, etc. Then you lay out your cans. We have a minimum requirement of 16. Depending where you look, they have a minimum of 20. Others say 24. But for our purposes, 16 will work. The key thing is that the number that you put out there must be divisible by 4, or rather the final calculations that you work with must be divisible by 4. Now, before you start, check those wind conditions, because if it's too windy, it will definitely distort the data. So the key number to remember is 5 miles per hour. There's this cool tool called an anemometer. You put it up in the sky, it whirls around and gives you the wind speed number. And then you run the system 10, 15, 20 minutes, depending on the type of sprinkler that you have. If it's conventional spray, it's running a little bit for a little bit shorter period of time. If you're working with those rotary nozzles, you will be running it for longer. Rotors as well will run for a little bit longer. Things to check. As the system is running, or actually before, you want to check your pressure, key thing. You're checking your static pressure, which is when the system is not running, and the dynamic pressure when the system is running. And then you also check the pressure at the heads once the system is turned on for the audit. You want to check it at the beginning head, and then you check it at the end to see what sort of loss you are getting in your distribution. And then once the test is done, you start the process of diligently, carefully reading the data. Ideally, you do it with a partner where one person is reading and the other person is recording the data. At the end of it, as you read each can, we strongly recommend you empty out the water and turn over the can so that you are tracking your progress through the data. And that brings us to the end of our module on irrigation auditing.